Now what is mole? Mole is a chemist way of calculating or chemist way of measuring large number of substances. This is a triangle, a calculation triangle for you to understand or to learn this formula in an easy way. And to understand moles, what is mole? Mole is a way of calculating, okay, it's a chemist way of calculating, and 1 mole is always equal to the molar mass or the formula mass or the atomic mass. Hello and welcome back, students. So this is going to be your last and final part of stoichiometry, part 6. If you have not watched the part 1 to 5, then go check that out. You will find the link in the description box below, and share it with your friends and family, whoever needs to watch these videos, and show your appreciation by liking the videos and subscribing to our channel. So let's quickly dive into it. So the topics we are going to cover in this particular videos is limiting reactant, concentration, titration calculation, percentage yield, and percentage purity. Okay, so let's without wasting any time, let's quickly dive into it. So the first topic is limiting reactant. So what is limiting reactant? For example, you are cooking something, okay, and one ingredient is less in amount or is limiting, okay, and you don't have another packet of it, or maybe you have to go to a market to buy that. So what happens? Because of this lesser amount of ingredient, the product or the cooking which you are doing will be affected, right? So the ultimate product or the ultimate food which you will get will depend on that amount, that limiting reactant or limiting ingredient amount. Similarly, in chemistry, when we react two reagents, for example A and B, okay, and if A is in lesser amount, then the product which is formed will depend on the concentration of A, okay, if it is limiting reactant. I'm writing LR, okay, and the reactant which is greater in amount, that will be known as excess reagent or excess reactant, ER. So let's quickly read about it. A chemical reaction stops when one of the reactant is used up. Definitely, if A is being used up completely because it is less in amount, so at that time there is no A left for B to react with. Therefore, the reaction will stop once the limiting reagent is used up. Okay, the reactant that is used up first is the limiting reactant. Okay, so the limiting reactant is the one which is used up first, as it limits the duration and hence the amount of product that a reaction can produce. Okay, so two things depend on limiting reactant: the amount of the product which we will get, and then the duration of the process. Okay, so if it is less in amount, definitely the reaction will stop at lesser time, right? Next is the one that is remaining is the excess reactant. So in this hypothetical example which we have we can see here is B is the excess reactant or excess reagent. Why? Because it is greater in number or greater in its concentration. The limiting reactant is the reactant which is not present in excess, definitely. Therefore, limiting reactant is what matters to calculate the final amount of product. Okay, next. Okay, so now how do we calculate or how do we identify limiting reactant? So there are 3 steps. 1. Convert the mass of each reactant into moles. First, we are going to convert it into moles. Then what we are going to check? We have to check the ratio of the moles. And thirdly, we have to look at the equation and compare the moles. Okay, let's try how do we identify limiting reactant by trying one question. So the question says NO2 is formed when this gram of O3, O3 is also known as ozone. Okay, so O3 is nothing but ozone, reacts with this gram of NO. What is the limiting reactant? So we have to identify the limiting reactant in this particular reaction. So they are saying NO2 is formed. So I will write NO2 on right side of the reaction because it is a product, right? And towards the left, what will I write? O3 and NO. So NO and O3 are reacting. NO plus O3 will give NO2 plus O2, right? Is this reaction balanced? The very important thing is to check if the reaction is balanced or not. So one nitrogen atom I can see on the reactant side, 1 on the product side, 4 oxygen in the reactant side, and 4 on the product side. So yes, we can move ahead. Now what is given? NO2 is formed when this O3 reacts with this NO. So we have to check which NO or O3, which one is limiting reactant. Okay, so what we are going to do, let's find out the moles. So if I'll find out the moles of O3, let's say moles of O3 will be, what is the formula of moles? How do we calculate moles? Moles is nothing but mass divided by molar mass, right? Let me write it down here. Moles equals to mass in grams divided by molar mass, right? Let's apply this formula and calculate. So what is the mass over here? Mass given for O3 is 0.740 grams divided by, what is the molar mass? So O3, how do we calculate the molar mass? 3 times 16, right? Because atomic mass of oxygen is 16. Okay, so how do we calculate the molar mass of O3? We'll simply multiply 3 with 16 and that will give you 48. Okay, now let's calculate this. This will give me 0.740 divided by, 0.740 divided by 48, and that will give you 0.015. Okay, then let's calculate the moles of NO, right? How do we calculate? Again the same formula, given mass upon molar mass. The mass which is given is 0.670 divided by molar mass of NO or nitrogen monoxide will be, nitrogen atomic mass is 14, okay, and one oxygen is 16. So if you will add 14 and 16, you will get 30. Okay, you will get 30. So we'll simply solve this. Let me calculate it quickly. 0.670 divided by 30, that will give you 0.022. Now the third step, the third and the final step is we have to observe and compare the moles. So can you see these two moles? Which one is lesser in amount? Definitely this 0.015 mole is lesser than 0.022. Therefore, I can say that the limiting reactant in this particular equation or question is O3. Okay, and the excess reactant will be NO. Excess reactant will be NO. Now quickly take a minute and note this thing down. Okay, now let's try one more question. The question says, let's consider the reaction between potassium and oxygen to produce potassium oxide. The reaction is given to you and this reaction is balanced. Okay, you have to always check if the reaction is balanced or not. If you have 12 gram of potassium and 16 gram of oxygen, let me write down 12 gram of potassium and 16 gram of oxygen they are mentioning. Calculate which reactant is the limiting reactant. Okay, the similar type of question we have just solved. So let's try if we can do this or not. Potassium and oxygen is needed. Okay, so let's calculate the moles of potassium and oxygen. Then let's check which one is limiting reactant. Okay, now for potassium the mass is 39. Okay, so we'll consider the mass of potassium to be 39, not 39.09. Next, the mass for oxygen is, we all know it's 16, 15.99, which is approximately 16. So let's calculate the moles quickly. So the moles, the first step is to calculate the moles. Okay, so moles is nothing. Let me write down the formula for you if you don't remember. How do we calculate moles? Moles equals to mass, which is given in gram, divided by molar mass, right? So now let's calculate moles. Moles will be 12 divided by the molar mass of potassium, which we have just checked is 39. Okay, and if you solve this, you will find, let me do it quickly with my calci. 12 divided by 39, that will give you 0.3. Okay, so 0.3 moles are given according to this question, right? And for oxygen it will be 16 divided by, now O2 is given, So for molecular mass, how do we calculate the molar mass? 16 plus 16, which will give you, right, like this, 16 plus 16, because 2 oxygen is given. If you solve this, 16 divided by 32, that will give you 0.5. Okay, that will give you 0.5. Now, from our balanced equation, I can say that from this balanced equation, I can say that 4 moles of potassium is 4 moles of potassium needs 1 mole of O2, right? So 0.3 moles, which we have just calculated for potassium, 0.3 moles of potassium will require how much of moles of O2? Okay, now what do? We simply cross multiply. If you will cross multiply, let me say this is x. So if you will cross multiply, it will be 4x equals to 0.3. X equals to 0.3 divided by 4. Okay, and this will give you 0.075 moles of O2. Okay, so for 0.3 moles of potassium, how many moles of oxygen is required? 0.075 moles of oxygen is required. But in the question, how many moles are given? 0.5, which is greater than that of what is required, 0.075. Hence, I can say, because the requirement is less and the one which is provided, the value of oxygen moles which is provided is greater. Hence, I can say that potassium K is the limiting reactant and oxygen which is in excess is the excess reactant, right? So I can say that the product which will be formed will depend on the potassium amount, right? Because it is in limiting reactant. Now quickly take a minute and note this thing down. I hope you have understood the limiting reactant part. Now let's move on to the new topic, which is very important, very interesting, concentration. Now what is concentration? Before we understand that, let's understand what are solute, solvent and solutions. So what is solute? Solute is that substance which we dissolve in the solvent, okay, and it is required in less amount comparatively. For example, let's take an example. You have a beaker. You add water in it. So water is your solvent. Okay, water is your solvent here. And if we add 1 tablespoon of sugar or salt, any solute you can take. If I add 1 tablespoon of sugar, okay, then this sugar becomes your solute. So the solute is the substance which we add in the solvent for dissolving it, okay, and it is usually required in less amount, okay, and the solvent is, in comparison to solute, the amount of solvent is greater. And when we add it, we will get a salt solution, okay. So the solution is when we add the solute and solvent, that's how we get solution. So solute plus solvent gives me solution, okay. Next, let's read quickly the definition. Solute is the substance that gets dissolved in a liquid, okay. Solvent, this is the substance that does the dissolving, or the liquid which we are mentioning on in the definition of solute, that's the solvent, okay. The universal solvent is water, we know that, right? Now what is solution? This is the resulting mixture when a solute is mixed with a solvent, okay, like for example salt solution or sugar solution, right? Next, now what is concentration? For example, this is one beaker, another beaker I am drawing here. Same amount of solvent is present in both the beaker. Let me say this is beaker number 1, this is beaker number 2. I am adding 1 tablespoon of solute in beaker number 1 and 2 tablespoon of solute in beaker number 2, okay, 2 tablespoons. So can I say that the concentration of solute is higher in the case of second beaker, because more of salt will be present here and less of salt will be present here? So if the solute is lesser in amount and the solvent is greater, then that type of solution is known to be a diluted solution, okay. So this will be your diluted solution or diluted solution. And then next one, in which the amount of solute is greater, okay, amount of solute is greater, then that is known as concentrated solution. Okay, concentrated solution. So can I say that concentration is nothing but it is the strength of a solution, that how much of solute is added, more the solute is added, more the concentrated our solution becomes. Okay, now quickly read. Concentration refers to the amount of solute there is in a specific volume of the solvent. This is the definition of concentration. Okay, so the amount of solute which is there in specific volume of solvent. Next, the greater the amount of solute, greater is the strength or greater is the concentration of that solution. Concentration is sometimes commonly referred to as strength. Okay, the greater the solute is, the greater the strength is, the greater the concentration is. Now, I have this image for you for better understanding of concentration. In A part, there is no solute added. Okay, in B part, there is 1 tablespoon of particular solute added. Okay, let's take copper sulfate or anything, whichever you wish to imagine. Then 2 tablespoon in the C part and 3 tablespoon in the D part. Can you see the color change? It is becoming darker in color as more amount of solute is added to it, right? So can I say, if I compare the B and D, then more amount of solute is shown by blue circles. Okay, so less amount of solute particles are shown in B, but more amount of solute particles is shown in B. This means that if the amount of solute is greater, it means that the concentration of D is higher. So I can say D is a concentrated solution, and B is your diluted solution. Okay, diluted means less, let me write down here, diluted means less solute. Okay, because only 1 tablespoon we are adding and 3 tablespoon we are adding in the D. So less solute, more solvent. Okay, that's what diluted means. Now quickly take a minute and write this thing down. Now let's move on and check few very important diagrams or very important formulas. How do we calculate concentration? Okay, so we can have 2 type of units of concentration, units, or you can say that it can be expressed at, we can also say unit. Okay, so 2 units, gram per decimeter cube and mole per decimeter cube. Okay, if we are taking our solute in gram, then we'll use the unit gram per decimeter cube. If we are taking our if we are taking the solute in terms of mole, then it will be mole per decimeter cube. Okay, then we can also convert the decimeter cube in centimeter cube. In few questions you will get the volume in centimeter cube. So how do you calculate? Say we have to convert. Okay, so how do you do the conversion? For the conversion, you should know that from centimeter cube to decimeter cube, if I have to bring anything, that I have to divide it by 1000, and from decimeter to centimeter we will multiply with 1000. Okay, next is your formulas. So how do we calculate concentration? Mass of solute divided by volume of solution. This will give me concentration. So definitely you can see that gram per dm cube becomes your concentration unit here. Okay, concentration unit. And when we are taking number of moles, okay, when we are taking solute in terms of mole, then the concentration unit becomes mole per dm cube or decimeter cube. Okay, there is also a triangle for you to better learn this formula. So this is a triangle, you can note this thing down. Next, okay, so how do we denote? In few books, moles are denoted with small letter n, concentration is denoted with small letter C, and volume in V. We all know that. Okay, so I would like you to write this thing down quickly, note this thing, and then we'll do the related questions to the topic concentration. Now let's dive into few questions. Let's check how much we have already understood about concentration. So the question says a student dissolves 12 gram. So what is given? The solute is sodium chloride or NaCl. Okay, it's a salt, we know. So the mass of salt is given to you, or mass of solute is given to you, which is 12 gram, right? Then in 1500 centimeter cube of water, so volume of solvent is also given to you. volume of solvent, which is water, is given to you, which is 1500 centimeter cube. Okay, we have to convert this into decimeter cube first. Calculate the concentration of the solution in 1 gram per decimeter cube and 2 mole per decimeter cube. Okay, so let's do the first part. Before that, let's first convert this centimeter cube into decimeter cube. So how do we do? 1500 divided by 1000 will give you decimeter cube. Okay, this will be 1.5 dm cube, right? So this is how we will do the conversion. Always remember, we have to do the conversion to get the right answer. Otherwise, your unit problem will happen. Now, let's do one by one. First, let's do the first part of the question, in which we have to find the concentration in gram per dm cube. So what is the formula of concentration? Concentration equals to mass of solute divided by mass of solute in grams divided by volume in dm cube, right? Let's put the values. This is the formula which we are using. If we put the values, we will get 12 divided by 1.5. Let me calculate it quickly. Okay, so 12 divided by 1.5, that will give you 8. Okay, 8 gram per dm cube, I can say. This becomes your concentration. This is your answer. Okay, next we have to find out the second part of the question, in which we have to find the concentration in mole per dm cube. So for the formula, concentration equals to moles of solute, moles of NaCl. Here the solute is NaCl. Let me write down. Solute here is NaCl and solvent is water. Okay, H2O. Then concentration equals to moles of NaCl divided by volume in dm cube. Okay, how do we calculate moles of NaCl? So formula of moles is moles equals to mass, the mass which is given divided by molar mass. So this is the formula we are going to use. And how do we calculate the moles? Moles of NaCl becomes mass of NaCl in gram divided by molar mass. So let's put the values. Mass of NaCl given is 12 gram. So 12 divided by, what is the molar mass? So sodium is 23 plus chlorine is 35.5. Okay, if you solve this, you will get 12 divided by 58.5, which will give you 0.2 moles. Okay, so 0.2 is the moles of NaCl. Now let's put the value of moles in this formula. Let me change the color so you don't get confused. Okay, so to find out the concentration, C becomes moles of NaCl, which is 0.2 divided by volume. Volume is 1.5. This will give you how much? Let me calculate. 0.2 divided by 1.5, and that will give you 0.13 mole per dm cube. This becomes your concentration. Okay, so the answer for first is this and answer for second is this. Okay, quickly take a minute and write this thing down. Now let's try one more question. Let's find out the concentration of a solution of sodium hydroxide NaOH in mole per dm cube. Okay, so this is important. You have to check always in which unit they are asking for the concentration. Okay, here they are asking in mole per dm cube. So what is the formula? Concentration equals to moles of solute divided by volume of solvent, which should be in dm cube, right? So make sure that we have to do the conversions and we have to find the mole. What they are saying, 80 gram of NaOH is dissolved in 500 centimeter cube of water. Okay, the relative atomic masses are given to you. These values will always be given to you in the question paper. So let's quickly find out the moles of solute. So what is the formula to find moles of solute? Moles is equals to mass divided by molar mass. So the mass which is given is 80 divided by molar mass of NaOH. So how many sodium atoms you can see? 1. So 23 plus 1 oxygen, 16 plus 1. Okay, let's solve this and then we'll find the moles. So 80, okay, 23 plus 16, let's do 17, so this will give you 40. So 80 divided by 40 will give you 2, right? 80 divided by 40 is 2 only, right? So moles is 2. Now we have to convert, the volume is given in 500 centimeter cube. Volume is 500 centimeter cube, which is given already in the question. We have to convert this into decimeter cube, so we'll divide this by 1000 and you will get 0.5 cm cube, right? So this is the volume, 0.5. If you solve this, you will get 2 divided by 0.5, that is 4. So 4 mole per dm cube becomes your concentration. Okay, becomes your concentration. The answer. Okay, pause and quickly write this thing down. So this was it about your concentration. I hope this is clear. How do we calculate the concentration? There are 2 units, gram per decimeter cube or mole per decimeter cube. The formulas are also similar. Okay, just on the numerator we'll write the mass if we have to find out the concentration in gram per decimeter cube, and we have to change the mass into moles if we have to find out the concentration in moles per decimeter cube, right? Very easy. Now let's move on to very important topic. Make sure that this topic is only present in your extended tier syllabus. Okay, so titration calculation. So what is titration? Titration is actually a method we use, or the process we use in our labs to calculate the concentration of an unknown acid or base. Okay, so acid and base titration is there in your syllabus. What happens that when acid and base reacts, they form salt and water, right? This reaction is known as your neutralization reaction. Why? Because acid neutralizes the effect of base and vice versa. Base neutralizes the effect of acid. Okay, this reaction is known as neutralization reaction. So while we are doing the titration, what happens? We add the known concentration of your acid or base, whichever we are trying to find out. So known concentration of, let's say, acid is added in the burette, and in your beaker through the pipette we add unknown concentration of, let's say, base. Okay, unknown concentration of base is added. Now what do? We add dropwise the acid into base, and we add the phenolphthalein or any indicator, okay, to check if the neutralization has taken place or not, to check if the concentration of acid and base have neutralized itself or not. Okay, so let's read it quickly. Titration are a method of analyzing the concentration of solutions. Okay, one will be given to you, the concentration of one will be known to you, and the other you have to find out. Next, acid and base titration are one of the most important kind of titration. This is only given in your syllabus. Titration can determine exactly how much alkali. Don't get confused, alkali is nothing but base. Okay, how much base is needed to neutralize a quantity of acid. Okay, the reaction I have already given, what is neutralization reaction and how it works. You may be asked to calculate. Okay, so 2 main important type of questions can be asked from this particular topic. Either they will ask the moles present in a given amount, okay, or they will ask the concentration or volume which is required to neutralize acid or base. The formula remains the same. Concentration equals to moles divided by volume, which should be in your dm cube. Okay, this is the same formula which we are using. The triangle is also the same. Okay, this triangle is going to be very helpful for you to memorize the formulas. Now let's try one question to understand this titration in a good way. So the question says, let me write down given from this. Okay, so a solution of 25 centimeter cube of hydrochloric acid. So can I say that acid volume is given to us? Acid volume is 25 centimeter cube. Okay, because we need the value in decimeter cube, so let's do the conversion here itself. It will be we'll divide it by 1000 and we will get 0.025 dm³. Okay, this is after the conversion. Okay, then was titrated against a solution of this NaOH. Now from looking at the unit, you can identify that the value given to you is the concentration. Okay, so can I say that concentration of base, NaOH is a base, so concentration of base is given to you, which is 0.100 mole per dm³. Right, what else is given? This centimeter cube of NaOH was required. Okay, so the volume of NaOH is also given to you, volume of base. NaOH is base, right? So this is also given to you, 12.1 centimeter. Let me do the conversion right here. So if you will divide this by 1000, you will get 0.0121 dm³. Okay, was required for a complete reaction. Okay, determine the concentration of an acid. What do we have to find out? We have to find out the concentration of acid. Concentration of acid. This we have to find out. So this is the part which is already given to you in the question. Now let's start solving this one by one. So the step 1 is to first write down the reaction. Okay, that will give me an idea of the ratio of moles which should be present. Okay, so the reaction is happening between HCl, which is hydrochloric acid, and NaOH. Right, so HCl plus NaOH, we know this is cation, this is anion, this is cation, this is anion. They will crisscross. Okay, double displacement will happen, and this will give me nothing but salt, NaCl plus water, which is H2O. Then we'll check if this reaction is balanced or not. Okay, so 1 and 2 hydrogen, 1 chlorine, 1 sodium, 1 oxygen. Yes, this reaction is absolutely balanced. Okay, so this was the first step. So can I say that HCl and NaOH should be present in 1:1 ratio, right? They should be present in 1:1 ratio. Your next step, step 2, let me change the color so that we don't get confused. Step 2 is to find out the moles of the known concentration of base which is given to you. Okay, this is the known concentration. I told you, right? The known concentration is always added in the burette. In this diagram, this is the burette, and the unknown is added in the beaker through the pipette, and this is unknown concentration. Right, we have to find out the concentration here. Then moles of base, let me write NaOH. How do we calculate moles of base? The formula is concentration equals to moles divided by volume, right? The triangle, if you remember. Yep. So here, how do we calculate the moles? So for moles, we have to multiply both of these. Okay, we have to calculate the moles of NaOH, so we multiply concentration and volume in decimeter. So let's do it. Concentration times volume. Let's put the values. Concentration of base is 0.1 and that of volume of base is 0.0121. Right, let's solve this and get the answer quickly. I have my calci with me. Okay, so 0.1 times 0.0121, that will give me 1.21 times 10 to the power minus 3 moles. Okay, so these many moles of base is present. Right, now for base to neutralize my acid, the number of moles of base and acid should be same. Right, so can I say that the moles were in 1:1 ratio? So if I have found out the moles of NaOH, then the moles of HCl will also be this many only. Right, moles of HCl will also be this much only. Let me write down. Moles of HCl will also be 1.21 times 10 to the power minus 3, right? Because they have to neutralize each other. It means the number of moles should be equal, right? Now the third step, the step 3 will be, now let's try to find out the concentration of, your acid. Okay, so now how do we calculate the concentration of acid? So concentration equals to Okay, let me show you the formula. If we have to calculate the concentration, what do we do? Moles divided by volume. Okay, moles divided by volume. So concentration equals to moles divided by volume. Okay, here we are in step 3, we are trying to calculate concentration of acid. Okay, now we know the moles of acid, which we have already found out in step 2. So the value will be 1.21 times 10 to the power minus 3 divided by volume is already given to you in the question here, right? This is the volume, 0.025 dm cube. Okay, after you will solve this, let me do it. So 1.21 divided by 0.025, that will give you 48.4 times 10 to the power minus 3 mole per dm cube. Okay, this will be your answer. This will be the concentration of unknown concentration of acid. Okay, so this is your answer. Quickly take a minute and write this thing down. I hope this is clear. You can also write down this answer as 0.0484 mole per dm cube. Okay, if you wish to remove 10 to the power minus 3, then this answer is also accepted. Now let's move on to another topic, another very interesting and small topic, percentage yield. Now what is yield? Yield is actually the amount of product which is formed. Okay, so usually what happens, the reactants which we are adding, for example A plus B gives your product P. Okay, if I am adding A 20 gram, B 20 gram, so ideally I should get 40 gram of product, right? 40 gram of product should be present, but usually this is actually your predicted yield. Okay, this 40 gram is your predicted yield, or I can say that this is your theoretical yield. Theoretical yield. But practically what happens, we do not get this particular yield 40 gram. Why? Because maybe there is some error while measuring 20 gram. Okay, it can be less or more than this. Okay, or something can happen like if the reaction is not completed and I am weighing the product, at that time also I will not get 40 gram. Okay, because the reaction is still going on. Another thing which can happen is while transferring A and B into each other or in some other beaker, maybe the complete 20 gram is not weighed, or maybe the some part of this 20 gram is sticking to the beaker wall, or while transferring something is lost. Okay, so the mass may be lost in this way, or maybe a gas is evolved, right? During the process of reaction, the gas is evolved. So this way the mass reduces. So actually the actual yield which I get, is usually lesser than the predicted or theoretical yield because of these reasons, right? So how do we calculate the percentage yield? Percentage yield is actual yield which we actually get divided by predicted yield, or it can also be known as theoretical yield. Okay, which in this hypothetical situation which I have shown you, 40 gram is your theoretical or predicted yield, and actual yield can be maybe 38 gram or 35 gram. Okay, which is usually less because some mass is lost. Let's check how this mass is lost, and all the steps which I have given to you, you can note down from this. So the reaction may not be totally complete. Okay, then errors may be made in weighing the reactant or the product. Maybe there are some error in the machine itself. Okay, or the whatever weighing scale we are using, maybe it has some errors. Then material may be lost in carrying out the reaction or in transferring and separation. So while separation or while we are transferring the material, at that time maybe some material sticks to the wall of the beaker. Hence that mass is reduced from the mass which we needed. Like 20 gram may not be weighed properly, it would be 18 gram or something like that. Okay, lesser in amount. So the equation gave us an ideal figure for the yield of a reaction. In reality, okay, this is what I was trying to explain. In reality, the actual yield is lower than the theoretical or predicted yield. Okay, the following are the reasons, like these were the reasons 1, 2 and 3. This can be expressed to percentage yield is actually the percentage of how much should I get and how much I am getting. Okay, so this is the formula. Let's try one question. In a reaction, the predicted yield of nitric oxide NO is 512 gram. So this is the predicted yield of NO. Let me write down here. Predicted yield Y equals to 512 gram. The actual yield is 384 gram. Then calculate the percentage yield. Now what do? We simply put the values in this formula. So percentage yield equals to actual yield. So actual is 384 gram. Okay, 384 divided by 512 times 100. Okay, because we are wanting our answer to be in percentage. Okay, now what do? We'll simply solve this. So 38400 divided by 512, and that will give you 75. So I will say that 75% is the yield. Okay, so it should be 100%, but because the actual yield differs from that of theoretical yield, that's why we will get 75%. Okay, quickly note down the important points. This part is important, that why do we get lesser yield than which is predicted or theoretical. Okay, so quickly write this thing down, then we'll move on. Okay, so let's try one more question. So the question says heating 12.4 gram of copper to carbonate. So 12.4 gram copper carbonate is taken, it is heated, and it produces 7 gram of copper oxide. Okay, what was the percentage yield of copper to oxide? So we have to find out the percentage yield of copper to oxide. So let me write down the formula. Percentage yield is equal to actual yield divided by predicted yield times 100. Okay, this is the formula which we are going to use. Actual yield is given to you. The value of actual yield is 7 gram. Now let's calculate the predicted yield. So how do we calculate the predicted yield? So from this reaction, this is a balanced reaction. Okay, the first and foremost step for any type of question is you have to check if the reaction is balanced or not. This reaction is balanced. From this I can say that copper carbonate and copper oxide are in 1:1 ratio. So I can say that 1 mole of copper carbonate required to produce 1 mole of copper oxide, right? But they are giving this in terms of gram. So let's now convert this into gram. Okay, so molar mass of copper carbonate, let's find this thing out. Copper is 63.5, carbon is 12 plus 3 times 16. This will give me molar mass of copper carbonate. So let me calculate this quickly. So okay, so 16 multiplied by 3 will give you 48. So this is nothing but 48 plus 12 plus 63.5. Now let's do it. 48 plus 12, 48 plus 12 plus 63.5. This is going to give you 123.5. Okay, so 123.5 gram, can I say? Okay, before this, let's calculate copper oxide molar mass also. So molar mass of copper oxide CuO equals to 63.5 plus 16, and that will give you 63.5 plus 16, that will give you 79.5. Okay, now very important thing. 1 mole from this equation, balanced equation, I can say 1 mole of CuCO3 produces 1 mole of CuO, right? Or I can say that 123.5 gram of CuCO3 produces 79.5 gram of CuO, right? Because 1 mole is equal to the molar mass or the formula mass or the unit mass. Okay, so this should be equal to this. So 12.4 gram of copper carbonate should produce how much? Now what we are going to do? Cross multiply. Okay, if you will cross multiply, or you can do it like this also, 79.5 divided by 123.5 times 12.4, that will give you the your predicted yield of copper oxide in grams. Okay, so let's calculate this. 79.5 multiplied by 12.4, this will give you 985.8. so 985.8 divided by 123.5, okay, divided by 123.5, that will give you 7.982. 7.982. So this should be your predicted yield. Okay, this much amount of copper oxide should be produced, but how much are we getting? 7. Okay, so do you get it? The actual yield is 7 gram and the predicted yield is 7.982. Now let's put these values. I'm doing it with another color. This is your last step, step number 3. This was your step number 2, and finding out the molar mass was your step 1. Okay, now step 3, you will write the formula first, and then percentage yield, we'll put the values, equals to actual yield, which is 7 gram, divided by the predicted yield, which is 7.982 times 100. Okay, this will give you your percentage yield. Let's quickly do this. 700 divided by 7.982. This will give you 87.6%. 87.6%. This becomes your answer. Take a minute and quickly write this thing down. Okay, now let's move on to your last topic of this video, and the stoichiometry topic. So, percentage purity. The crude product may prove to contain less than 100% of required substance. Definitely we know that nothing is pure. So a crude material will definitely have some impurity in it. So it is not 100% pure. So what do we do to check the percentage purity? Mass of pure product divided by mass of impure product times 100. Okay, this is the formula. Let's read. The percentage purity of a chemical product can be calculated in a similar way to that of percentage yield, which we just calculated. Percentage purity is, now this is important, this is your definition for percentage purity, a measure of the purity of the product from a reaction carried out experimentally. Okay, so the formula is given to you, you can note this thing down, and then let's try the question. So the question says a sample of 20 gram of impure, now this is impure calcium carbonate, okay, impure, contains this of calcium carbonate. So what is the percentage purity? So what do we do? Percentage purity equals to, what is the mass of impure? 20 of mass of impure, and that of pure is 18.5, okay, times 100. We'll solve this and we'll get the answer. 1850 divided by 20, this will give you 92.5%. so I can say that this is 92.5% pure, because from this I can get, from 20 gram of that particular substance, I can get 18.5 pure calcium carbonate. I hope this is clear. This is your answer. Take a minute, note down the important definition, formula and this question, then we'll end this video. Okay, so here we come to an end of your part 6 of stoichiometry. I hope this helped you to understand the concepts well. If you have any doubt, you can feel free to comment down below and I'll get back to you. And we'll meet with more such interesting and informative videos. So till then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.